Hello. Today I have this question. Let's read it. It says that box may have any series combination of L, C, and R, and column 1 represents source current, and column 2 represents the possible statements. So we have V source as this, and I source after some whatever thing there is in the box, like this, and we have to match this. So let's say that V source is some V naught sine omega t, because obviously we can see that this is a sine wave here, and let's try to write the equation of the source. The wave is almost identical to the source here, so I can write it as I is I naught sine omega t. Now similarly with this, looks like a cosine wave, so I can add pi by 2 here. Now this is not a typical conventional wave, like this is not a sine function or a typical cosine function. So let's see how can we write the equation of this wave. Let's open Desmos here and see what happens if we add something to the sine x plus a, like the a is addition, so I add something. So the blue wave, which is the wave where we have added something to the x, is actually moving backwards, so to speak, and finally it becomes cosine like this, and sorry, this becomes negative sine because 3.1 is pi, almost pi, so the wave has reversed, and 1.57 is the cosine, and you can see that it is cosine function. So on addition, the wave actually moves backwards. So here also we can see, right, like this is the wave, and if I pick it up, oh sorry, this is the wave, let me draw it here. This is the wave, and this is the wave where we have to write its equation. So if I pick it up and align it here, you can see that it has moved slightly backwards. So I can write it as I naught sine omega t plus, some phi. Phi belongs to 0 to pi by 2, so that the phi is not so big that it has become a cosine wave, but it is just enough that the wave has moved backwards slightly. It has not become cosine, but it has moved backwards. Now let's see how we can identify this. Now this wave, if we look at this wave, you can see that it has moved ahead towards the positive x-axis slightly. So this is ahead, this is right here. If I take it the same thing here, if I take this sample here, the sample has moved actually forward, so we have this bit of graph here left. So let's see what happens if we subtract. You can see that the wave on subtraction moves forward, the blue one moves forward, so we have to subtract something like this. The blue has moved forward, and we see this bit of a graph as in visible here. So it is also I naught sine omega t, and minus phi. I'm sorry, let's continue. So we were here that on subtraction the wave moves forward, and the subtraction is not up till pi by 2 because the wave has not become completely cosine. So this is our waves. Now let's see what the column 2 has to offer. Box, so let's draw a phasor in this case. This is VL and this this is VR and IR here, and this is VL and this is VC. And since this is a series combination, the current remains the same, the voltage actually changes as we have studied in LCR circuits. So let's see when this same wave is actually formed. When L and C, then when VL and VC are equal, or at the state of resonance, or when there are no VL and C altogether. That means that there are no L and C, there is no inductor or capacitance in the circuit, or the voltage across capacitor and the inductor and capacitor are equal, and that is called state of resonance. So A part corresponds to state of resonance. Box may contain LCR, yes, may contain LCR, but there is state of resonance. Power factor, no, this is wrong for first part. And let's see the power factor. And the power factor is cos phi. Cos phi is the power factor. Cos phi is 0. Phi is 0 in this case, right? Because there is the same wave is being replicated. So phi is 0, so cos 0 is 1. So actually the power factor is maximum here. So the power factor is not 0. So we can write that A matches with P and T. Now for the B part. IR, first of all let's find the power factor. Phi is pi by 2, so cos pi by 2 is 0, so the power factor of the box is actually 0. So R is already matched for this. Let's see if the box may contain LCR. So if the box contains LCR, say the voltage across inductor is more than capacitor, so this will be the VL. And in this case, uh, voltage leads the current. Voltage leads current because we have to add some theta to reach the phasor of uh, the final voltage, the net voltage. So the voltage leads. Or if volt, or this graph may also come here at theta, and current can also lead in this case. So the answer to this will be P. Box may contain LCR. If there is LCR, you know this angle can never be pi by 2. Well, why? Because for this vector to reach here, this has to be 0, or for it to reach here, this L should be 0. So P is not the right option here. It is either LR or CR. Now we have to see whether current is leading or voltage is leading in the B part. So how we will test that? Let's see. Let's find out together. Now let's assume that VC is 0. So the final voltage will be as such. This will be the V net. The phasor of V net will be like this. And since the IR, since we have to add something to IR to get to V net, so voltage is ahead. We can say voltage is ahead in this case. But in B part, we had to add to voltage to get to the I. But here we had to add to I to get to voltage. So the this assumption that voltage is ahead is incorrect. So there is no LR in this condition, there is CR. I have told you this through like negation, but let's also try to prove it. Say there is this VL is 0 and we have just VC, and this is VR and also the IR phasor. This will be our V net, and adding to V, adding positive, because anti-clockwise is taken plus and anti-clockwise is taken negative. So when we move anti-clockwise, we take positive, and this is a convention in angle in radians. So we have taken, so we have moved positively anti-clockwise and we have reached the current. So current is leading in this case. In this case the current is leading, and we added to voltage to get to phi. So we added to voltage to get to IR, and here also we added some phase difference to voltage to get to I naught. So B matches with RC. So B matches with RC, so S and R are the correct options. Now similarly here, now we will not take too much time and do it again in this part. Say this is the V source phasor, and this is the I phasor, I source in C part. This is the V source and this is the I source. Why? Because we had to add to the phasor of we had to add to the phasor of voltage to get to the I source. We have to add some theta here, some phi here to get to the I source. So I source is ahead of V source. Now let's see when this is possible. We have VR here and IR here, VL, VC. When is it possible that current is ahead? When there is just CR, right? Because then only will the V net will be before IR. V net will be before IR, and here also V net is before IR. So this matches with CR. Box may contain only CR. So S, state of resonance no, power factor not 0 because phi is not pi by 2, and box may contain LCR no, box may contain only LR no. Let's see this one, the D part. In the D part, this is the V source phasor and we have to subtract to get to the I source. Let me draw it properly. And we have to subtract to get to I source. So voltage leads here. This is D part and voltage leads here because this was the V source. This was the V source and we have to subtract phi. So we will move anti-clockwise, subtract phi and get to the I source. So actually V's voltage is ahead of I in D part. And let's draw a general phasor as we studied in AC circuits. This will be when this can also happen when the vector phasor, net phasor is like this, because then we'll have to subtract to get to IR. So LCR circuit is possible, but only when VL is more than VC. So LCR is still possible, but VL should be greater than VC. So box may contain LCR or the box may contain only LR. So there is no state of resonance. So in D part we have just Q because voltage is ahead in this case of the current, so it may be only LR or the box may contain LCR. And similarly I forgot here also, In this case, in C part also, we had to add to the V source to get to the VI. Sorry, to get to the I source. And in the general conditions, just general phasor, when VC is greater than VL, this phasor can also form. So box may contain LCR, but VC should be greater than VL. So yes, P is also possible in this case. So now let us see if what I have spoken is true or not. Let me fetch the answer key of this question. This one is actually paper 1, part test 1, paper 2. Part test 1, paper 2. No, we don't have part test 1, paper 2. I think I had it on Google. Yes, we have it on Google. This is question section 4, question 1. PTRPSPQ. 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 So we got this one wrong. S won't come here. Let's see why did we get this wrong. B matched with only R. And not S. This can also be correct, or it may be incorrect. Let me see my own answer key and verify. The paper was actually conducted on 11th of April. This is the 37th question, and yes, A is matched to only P, B to R, C to PS, and D to PQ. They have matched A to only P. What did they match? A to. They matched A to PT. Well, let me see the actual answer key of this. So we have just got this wrong. Let's see why. This is our V source, and the I source is leading by pi by 2. So this is our VR and IR. This is VL and this is VC. V source should be, so VL should be, VL should not be anything, and the V net vector should be like this. But if we have some r here, some vr here, the vector will also always be at some angle, but we just want the v net to be like this. So it would be just c connect, so it will be only c connected. So just capacitor connected to some voltage. This will be the circuit. So just C circuit, capacitor only circuit. So that's why S is not the correct option here. May contain RC, because if some C is there, the vector will always will be inclined at this and never at pi by 2 what we want. So yeah, that's about it. Thank you. I hope I learned something from using phasors and Desmos to find what sine function is ahead and what is behind.